Good morning, grade 10. Today we will explain the second lesson in fourth quarter, which is angle bisector theorem. Let's read our theorem. If a ray bisects an angle of a triangle, then it divides the opposite side of the triangle in two segments that are proportional to the other two sides. Again, if a ray bisects an angle of a triangle, like this ray, bisect an angle of a triangle means, bisect here means divide this angle equally. So this line, it divides the opposite side of the triangle, as we see here. It divides the opposite side of the triangle in two parts. The two parts are proportional to the other two sides. So we can say that our proportional is A, the length of A, over the length of C equals the length of B over the length of D. And the order of the proportional here is very important. Let's see an example on this theorem. Find the value of x. We have here a triangle ABC, and we have the length of AC equals 18, the length of CB equals 24, the length of AD equals 12, and the length of DB equals x. We want to find the length of DB. So here, as we see in our triangle, we can say that the angle C has we have here CD is a bisector. Bisector here means it divides angle C equally, as we see in the example here. These two signs mean that the two angles are equals in measure. So of course here we can use our theorem, angle bisector theorem. So the first ratio or our proportional will be CB over BD equals CA over AD. By substituting the length of each side, so the length of CB equals 24, the length of DB equals x, so 24 over x equals 18 over 12. Of course here by cross multiplication we will find the value of x. So x here will be 24 times 12 divided by 18. So the value of x will be 16. Another example, also here I want to find the value of x. Before using our theorem, we must check that we have the condition for our theorem. The condition of our theorem here that if I have a line or a ray bisect an angle of a triangle. So we have here these two signs mean that the measure of the two angles are equals in measure. So this will be a bisector. So we can use here our theorem. So the sides will be proportional. BA over AD equals BC over CD. By substituting the length of each line segment, so 5 over 3.5 equals 12 over x. By cross multiplication, we will find that x equals 3.5 times 12 over 5. So x here equals 8.4. Let's see another example. Here also we have application on theorem 2, angle bisector theorem. We have a triangle and we have a bisector here, and these two angles are equals in measure. So we can use here our theorem. So the sides here will be proportional. So which sides are proportional here? Of course, this side, which is 5 over x, very good, equals 7 over, yes, I have here this line segment or this side is missing. I don't have the length of this side, but I have the whole side equals 8, and this part equals x. So who can guess how can I find the length of this side? Excellent. It's 8 minus x. So I found this part, so I can start to write my proportional. My proportional now is 5 over x equals 7 over 8 minus x. Also here, by using cross multiplication, I can find the value of x. So 7 times x equals 7x equals 5 times 8 minus x. So 7x will be as it is. 5 times 8 equals 40, and 5 times negative x equals negative 5x. By collecting here the like terms together, so 7x plus 5x equals 40. 7x plus 5x equals 12x. So 12x here equals 40. Of course, by dividing by 12, x equals 3.3. Let's see another example. Here another example. I have a triangle and I have a bisector here. It's very clear that I have a bisector because the two angles here are equals in measure. So I want to find the value of x. So of course our proportional will be 10 over 8, excellent, equals 5 over, what about this side? I want to find the length of this side. Like the last example, I will subtract. Very good. I have here the whole side. Here equals 3x minus 3, and here equals 8. So this side will be 3x minus 3 minus 8. So let's write our proportional. 10 over 8 equals 5 over 3x minus 3 minus 8. By cross multiplication, or by simplifying first this part, so 10 over 8 equals 5 over 3x minus 11. Use cross multiplication now. So 40, because of 8 times 5 equals 40, and 10 times 3x minus 11. So 40 equals 10 times 3x equals 30x, and 10 times negative 11 equals negative 110. By collecting the like terms together, so we have here 40 plus 110 equals 30x. So 40 plus 110 equals 150, equals 30x. By dividing by 30, so x equals 5. Okay, let's now compare between theorem 1 and theorem 2. Theorem 1 here, we took it the first lesson. We said in theorem 1 that if a line is parallel to one side of a triangle and this line intersects the other two sides, it divides the sides proportionally. So of course, to use theorem 1, we must have the parallelism here. We must see the parallelism here of the two parts. This side parallel to this side. But in theorem 2, we have if a ray bisects an angle of a triangle, then it divides the opposite side into line segments that are proportional to the other sides. So to see or to use theorem 2, we must see the bisector and we must see angle in a triangle bisects by a bisector. So theorem 1 we have parallelism, and theorem 2 we have bisector, or we have angle bisects by bisector. So this is the difference between theorem 1 and theorem 2. It's too important to know the difference between them. Of course, our homework inshallah will be booklet page 118 and 120. Thanks, great time for listening, and have a nice day.